We are honored to have with us distinguished leaders, academicians, policymakers, and passionate advocates across the globe. Your collective expertise is our most valuable assets in tackling the challenges and opportunities that lie on soil. Soil is not only the foundation of agriculture, it is also one critical part of our ecosystems. And here I highlight ecosystems. It is the foundation of food security, biodiversity, and also our global fight against climate change. This conference aims to transform the way we think and also how we understand soils. Over the next 2 days, we will engage in a series of conferences, also panel discussions, and interactive roundtables. Each session is designed for you to foster learning, inspire action, and facilitate collaboration among us. We begin our journey with opening remarks from our esteemed President, Mr. Hisham Habti, followed by a presentation on the essence of the table ronde, the essence of les tables rondes de l'Arbois by Professor Daniel Nahan, followed by our inaugural speaker, Mr. Dominique Strauss-Kahn. Please join me in welcoming Mr. President, Mr. Hisham Habti.
Thank you, Manal. So Manal, I knew her as a faculty at UM6P. Now she's MC of this event. So this is what UM6P is about. It's just giving the opportunity to everyone to be as agile and flexible as possible. So thank you so much, Manal. Assalamu alaikum. Bonjour, ladies and gentlemen, esteemed guests. It is with great pleasure that I welcome you all to, and you have to add something, les tables rondes de l'Arbois et de la Méditerranée, otherwise Professor now will get upset. No? Okay, here at UM6P, our gathering, as Manal said, reflects that we are reminded of the critical juncture at which our continent stands today. As you may know, agriculture is core and center of the African economies. It is key not only to feeding the ever-growing population, but also in driving economic growth and sustainable development across the continent. Here at UM6P, our commitment to agriculture extends beyond traditional farming methods. We are investing to advancing research and technologies that preserves and enhances the fertility of our soil to ensure a sustainable food system for future generations. The role that we set for our university goes beyond education and research. We work on developing practical applications that have direct impacts on agriculture practices. Such hands-on approach not only tests the viability of scientific theories, but also ensures that our students and researchers are actively involved in solving the challenges facing our farmers nowadays. The Table Ronde de l'Arbois et de la Méditerranée serves as a critical platform for this mission. Over the years, this conference has become central to exchange groundbreaking ideas that bridge the gap between scientific research and practical applications in agriculture and environmental conservation. Today, we are honored to host this event, which not only echoes our dedication to sustainable development, but also aligns with our strategic vision to place Africa at the forefront of scientific and technological innovation. I invite each of you to engage with the rich agenda we have prepared so far. Share your insights, challenge the status quo, and let us collectively harness the power of innovation to transform African agriculture into a model of sustainability and efficiency. Ladies and gentlemen, esteemed guests, thank you for your commitment to this cause, and once again, welcome to this 16th edition of les Tables Rondes de l'Arbois et de la Méditerranée at the University of Mohammed VI Polytechnic. Thank you so much.
Thank you, Mr. President, for your inclusive approach and also for giving us a space to grow and also to innovate and implement our ideas. Thank you very much. Please join me to welcome the spirit of les Tables Rondes de l'Arbois et de la Méditerranée, Professor Daniel Naon.
Hello. I will speak in English. Les Tables Rondes de l'Arbois were created by Jeanne-Marie Parly and myself 17 years ago. It is a scientific popular culture event with prestigious speakers. The goal is to bring to the public the major scientific advances from which society benefits for its sustainable development. In 2024, these Tables Rondes de l'Arbois have become a Moroccan event and hosted by UM6P, founded to serve the development of all of Africa. Since you have been president of this university, Hicham El Habdi, you have played an immense role in the development of research and innovation in Africa. The recognition of the involvement and extraordinary commitment of the University Mohammed VI Polytechnic in the development and training of a young Moroccan and beyond African elite was greeted by the most prestigious American and European universities. Thanks to UM6P, a major technological leap is taking place in this continent, which is nothing other than a quarter of the emerged lands. But the work is only just beginning. We are facing harsh realities. The world is making a mistake. It has based its development on GDP. We know that the GDP is 90 years old. It is a measurement of social performance, perfectly correlated with the development of fossil fuel energy. As far as global environment is concerned, this caused adverse impacts. And since creation of IPCC in 1988 until today, the production of coal has doubled, as has that of oil, while the use of fossil gases has increased by 60%. And this, despite of all the promises, despite of the commitment of the nations at the various COP. When the IPCC was created, the scientists who made it up forgot half of the problem, namely the contribution of land users. focusing their attention only on the combustion of fossil resources, that is to say, on energy. The IPCC's error is not to have considered the importance of land uses from the outset and not to evaluate it from 2010 at its fair value. The simple and linear reasoning of considering that by stopping the consumption of fossil fuel, we would stop the climate from warming is faulty carbon accounting. Because the world is a complex system. No real-world problem can be solved in a linear fashion. All on Earth works by bifurcation. So global warming, but also all the other transitions that our societies are experiencing, but must be analyzed in a multimodal way. Everything our universities don't teach enough. It is the same for greening of Africa. Each natural system, climate, soil, forest, water, energy, human, animal, and plant biodiversity is being considered unique with an autonomous history, with its physical and chemical laws. But these systems are all linked together and generate antideterminism. Their level of organization are nested like Russian dolls. Water security, food security, climate change, loss of biodiversity, ecosystem services delivery, and green energy are our major societal challenges and should therefore be treated at the same time. It is mandatory to obtain a less carbonaceous atmosphere. The common denominator to all these challenges on which we should act is healthy soil, the only resource that it's not renewable at the time scale of the human life. Healthy soil, remaining the only carbon reservoir to be used urgently to impede global warming to soar. Massive digital resources must accompany all these scientific initiatives. They will allow us to act quickly. We now know that African soils are different from European soils. This is why African soils must be worked differently and why the use of fertilizers is essential. Africa is also where the population is likely to shortly double. We know that in Africa, droughts, water shortages, food needs, erosion of arable soils, desert advance, access to electricity, deforestation, and loss of biodiversity are most acute. These are compelling reasons for priority must be given to Africa in the face of climate change, and also to stop to consider that the economy is at the center of everything. On the contrary, an ecological vision of the world must be primary, and the economy must become a subpart of it. I would like to thank very sincerely all the scientists and personalities who agreed to participate in this event. And also thank the UM6P team who, around Khalid Badou, worked on the grueling organization of these days. Hind, Zineb, Miriam, and so many others. Thank you. Bonne table ronde.
Thank you, Professor Nahon. From Professor Nahon's speech, we can understand what really we can do if we love what we do. And here we know that passion and consistency can drive change and also enhance our resilience to all the topics Professor raised related to climate change, loss of biodiversity, etc. So time to invite Mr. Dominique Strauss-Kahn for his inaugural speech.
Mr. President of the University, dear colleague, ladies and gentlemen, when asked about African soils, the first things to come to an economist's mind is obviously agriculture and food security. But this question, important as it is, doesn't cover totally the whole vast subject that you have chosen for this roundtable. So let me first start with this question of agriculture, and I'll come later to something a bit different. The problem is rather simple. A, Africa is struggling to ensure food security, with a result that the most vulnerable are in a state of permanent insecurity. And B, today, many people believe that beyond the classical productivist model, the success requires a more holistic vision to take into account the nexus of water, food, energy, and including all kinds of scientific research that have been made during the last decades. So first, let me emphasize for a few minutes on how disappointing the African agricultural model has been since the independence of these countries. Per capita cereal production in Africa has grown very little since the 60s. The production today per capita is slightly the same as at the moment of the independence. Not more, not less. In contrast, in Asia, it has more than doubled. Where does the difference come from? It's mainly due to yields. Cereal yields, for instance, have risen in Africa from 1 ton per hectare at the beginning of the 60s to 1.8 today. In Asia, during the same period, it has grown from 1 to 4. That makes a very big difference at the end. And of course, it's connected to what Professor Nahon just said about the difference of African soils and the need of fertilizer, for instance. The result is a growing dependency. First and foremost, food imports. On average, African countries do import over 50% of the cereals they need. I'm taking the cereals as an example, could say the same thing with many other foodstuff. This makes them very vulnerable to surges in world prices. So much so that in 2025, the continent's food import bill is expected to be over $100 billion. But Africa is also dependent on imported input, not only directly food. And this is limiting a lot the benefits of local production. If, for instance, Africa was producing all the cereal they need locally, these countries will still be dependent on important fertilizer and plant products that they need. The sensitivity to this question is extreme. Let me take the example of year 2022 when the war between Russia and Ukraine began. We contemplate a drop of 25% of the fertilizer consumption in the continent, which means that an event that took place thousands of miles away had a huge consequence in terms of cost of the import and, of course, at the end of the day, the quantity of import. This vulnerability to world prices is exacerbated by the exchange rate liberalization policy that has been carried in African countries. Since the 90s, African countries have largely liberalized the exchange rate. But at the same time, the dollar, the US dollar, did appreciate a lot against African currency. As a result, import bills have continued to rise. The most flagrant cases of this are undoubtedly Egypt and Nigeria since 2022. And often, I regret to say, but this is following the questionable IMF injunction, especially at the beginning of a program. So, the point is that this productivist model comes up against a number of difficulties. First, it's obviously the environmental difficulty. I see here four concerns. Firstly, intensive farming pollutes water through the use of fertilizer and the creation of so-called dead zone. From this, the result is a decline in fish population. And at the end, the production of cereals, low in protein, is then to the detriment of fish farming, rich in protein. That's the first kind of problem in the kind of food African countries may have at their disposal. Secondly, intensive exploitation requires significant water resources. The strategy has, unfortunately, been often to exploit exhaustible resources, typically the case of the approach used in Niger. Historically, we know what it means. The case of the Aral Sea is very well known. Now, the 90%, 90, of the volume of the sea has disappeared to irrigate cotton. Thirdly, in the longer term, there is a problem of soil exhaustion. Monoculture tend to deplete soils, as everybody knows, and those soils are already poor in the intertropical zones. That's why labs on the quality of soils, like the one which has been developed recently in Togo, is very important, probably a leading lab in Africa, where a total mapping of the soil of the country has been done and should be repeated in other countries. And fourthly, the biggest environmental problem is undoubtedly the impact on biodiversity. We have a European example on that. In Germany, intensive farming has contributed to a drop of 80% in the insect population of, over the 40 last years. In Europe as a whole, the bird population is declining by 20 million a year. So this example, which took place in north of Africa, have no reason not to repeat, even maybe even strongly in Africa. Clearly, no need to develop more. The environmental consequences of this model are therefore considerable. But at the same time, for me, it would be a mistake to underestimate the economic problem of intensive agriculture in Africa, even if the environmental question is probably today at the forefront. The main problem for me is that small-scale producers simply don't have the means to accumulate the inputs they need for the next season. As a result, they have to borrow a lot at the start of each season, which makes them more fragile. And if, for some reason, there is a crisis, their land risks being seized and people are forced to migrate to towns, contributing to chaotic urbanization. Typically, what has happened in Zambia and Tanzania, where the Gates Foundation has an initiative to promote fertilizer, is very illustrative. It has resulted in farmers becoming heavily in debt and being just unable to face any kind of forthcoming crisis. So, having said that, it seems clear to me, and probably to many, that we need another model, which brings me to my second point. African agricultural policy must obviously evolve in the face of the climate change. To begin with, I would like to make two small introductory remarks. The first is what climate change is increasing the rainfall variability. You must know that less than 2% of African agriculture is irrigated. The rest depends on the rainfall. So if the rainfall begins to be chaotic, the problem will be huge in terms of yields. The question of irrigation is therefore of the biggest importance. And secondly, second introductory remark, which may seem anecdotal, but is not, is that warming will make outdoor war more complicated. Let me remind you that with 80% of humidity, it's difficult to survive over 39 or 30 or 40 degrees Celsius. And this is bound, obviously, to have an impact on productivity. Beyond these two remarks, it's clear to me that the main adaptation of African agriculture to climate change is linked to the financing problem. I'm not saying it's the only problem. There are a lot of scientific problems I'm not expert on. But the financing problem is clearly part of the problem, and maybe a big part of the problem. Because the required investments are massive, the World Bank says that the need will be about 15 billion a year for agriculture in Africa. In my view, it's rather underestimated. And what we need to find is a way to propose to those countries available means of financing. The idea, which has a lot of support in the last years, but probably decreasing support, that we can rely on the private sector is largely an illusion. The private sector today accounts for 2% of the adaptation finance in Africa, without going into details on the greenwashing effect of the so-called green finance. So I'm not saying that nothing can come from the private sector, but obviously if something has to be done and something has to be done, it has to be publicly financed. Raising this question of public funding, I'd like to share with you a thought that I initiated over 10 years ago. And in a nutshell, the idea is that the international community should ask the IMF to issue a sizable and recurrent allocation of special drawing rights, the so-called SDRs, the DTS in French, to finance the needs arising for climate change. I must admit that almost no one likes this idea, but still I will try to push it forward. No one likes the idea. Why? The IMF itself is reluctant because the SDRs haven't been created for this purpose, but I think that's not really an argument. The instruments need to be more easily, flexibly, And during the global crisis in 2009, the IMF decided under my leadership to an extraordinary allocation of SDR, which hasn't been created for that, but was very useful at the time, which helped assures foreign currency liquidity and trades globally. Probably we won't have been able to get out of the crisis without this special allocation of SDRs. But it's not only the IMF. Finance minister will not support my idea very much because they argue that this will fuel moral hazard and encourage investment with dubious economic and environmental returns, which is true. But this argument holds for any sources of financing. The question of the quality of what is done is a question, but it's not directly linked to the source of the financing. It's true also for any kind of development aid. The biggest criticism comes from central bankers because it appears erratic to monetary rigorists that will fear inflationary consequences of such an issuance of SDR, which in one way or another looks like a creation of money. This is a red herring. The amounts which are needed, let's say 100 billion a year, is about 0.1% of global GDP, which means that if all this transfer immediately into inflation, which will not be the case, it will be 0.1% of inflation more. If you need 200 billion a year, it will be 0.2% of inflation more a year. It's almost negligible, but more than that, it seems to me totally irrelevant if we really believe that the climate challenge we face is threatening human life on Earth. We cannot say that the future of humanity is at stake with climate change, which I do believe, and consider that 0.2% of inflation, of global inflation a year, is something unsustainable. We have to choose, and I think that one day or another we will have to make this choice. But, of course, this is a bold step which would radically change the nature of the problem. I hope the opportunity will be taken, but there's also a risk that we will miss it. This requires major decisions, both political courage and long-term vision, but as you know, long-term concerns often fade away in the face of urgency of the moment, and that's why all the promises which has been described by Professor Naon has been said one day and fade away the day after. On top of that, multilateralism today is not really in a good shape, which means that a collective decision on something like that is very difficult to make. Still, I believe that even if, again, the financing problem is not the only problem that we face, it is a key to find a solution, and there is no other way to find it than this step forward. Things like that, without tools, I don't want to develop too much on this, time is going away, but when the Dutch in the 16th century had the problem of the polder, it was an existential question. They have to solve it, whatever the inflation consequences, whatever the budgetary consequences, and they finance it in a very heterodox way, which I don't want to describe now, but just to illustrate the fact that when you're really facing something which is a huge threat, you need to accept exceptional way to solve it. Let me come now to my third and final point. Soil isn't just about agriculture and climate change. Soil is much more than that. In Africa, even more than elsewhere. Soil is also a space. And I would like to sketch out a few ideas. First track, soil is first and foremost a space on which we live. That's why I want to start with a few words about the question of urbanization. African urbanization has long been perceived as an obstacle to development. But there's a growing number of studies that are forecasting a growth of urban population in Africa over 1 billion, 1.2 billion in 2050. And these figures are forcing African policymakers and also international organizations to see African city not as a result of a chronic underdevelopment, but as an essential levers for growth. So we are in a period where the view on this is changing. Unfortunately, many of Africa's urban development strategy are based on concepts such as smart cities, sustainable cities, inclusive territories, which are sometimes more than a little vague. This leads to getting lost in an accumulation of measures that are impossible to prioritize. I think we have to go straight to something simple. From my point of view, African cities have to focus on three central challenges: health, safety, and mobility. I don't have time now to develop this point here. I would like just to take a minute to emphasize on another question of soil and other phenomenon which has to do with urbanization, which is the fact that African cities have remained outside the so-called movement of metropolization. While you have 4 African cities, namely Lagos, Kinshasa, Luanda, and Abidjan, among the 50 biggest cities in the world, you have none among the 100th city, the 101st city in terms of GPU, meaning a gross urban product, because the cities are very populous but don't produce a lot. The metropolization process didn't work. And the first city in terms of metropolization, in terms of gross human product in Africa is Johannesburg, but it's ranking only at the 159th rank in the world. So I think that is the first track, that a study of African metropolization and its consequences on the hinterland seems, I think it's a very important and fruitful field of research from the coming years, from the use of soil point of view. Second track, don't be afraid, I only have 3 of them. Second track, that I said that the ground, the soil, is a space on which we live. But also, it's the space you live in if you can. And sometimes it's the space you have to leave. This brings me to the second track, which is the question of migration, which is directly linked to the soil question. Migration in Africa is nothing new. Its many facets are very well known. Limited economic opportunities, armed conflict, repressive governments, and a more recent but massive factor, climate change. Over the last decade, the number of internal migrants within African countries has almost doubled, from 13 to 25 million. But of course, it's migration to the north and above all to Europe that is becoming a major political issue, fueling all kinds of demography. Demography in Africa, combined with climate change, will render many areas unfit for human habitation. This could increase the number of migrants rushing to Europe by a factor of 10. Numbers will no longer be tens of thousands, of hundreds of thousands like we see now, but millions. Under this condition, any policy based on authoritarian limit on the number of new arrivals is doomed to failure. The way forward must be to be able to keep this population to remain in their country of origin by creation of attractive prospect for human and professional development. Europe is today at the front line, more than any other part of the world. The question of Africa development is no longer a question of justice, as it has been when I was a young man and fighting for this. It's no longer a question of even of potential market that many can look at. It's an existential question to which the European Union is slow to provide the slightest response. In my calculation, an annual program worth 20 billion euro is needed to devote it to this cause. All arguments, economic, moral, others, against this are interesting. They are ranging from the difficulty to finding viable project, which is true, to the risk of corruption, which is true also. But they are well known. None of them will stand up to the pressure that will be exerted on the countries of the North if they are unable to keep Africans inhabitants in their own countries over the next 30 years. Are we going to have war and weapons at the European border in the south to avoid millions of people coming from Africa? No. Are we able to have this million of people coming from Africa in our different countries year after year? Probably not. So there's no other solution than helping them to stay at home, but helping them means a lot of millions of euros, of billions of euros, and the European Union has to realize this, which unfortunately seems not to be the case today. And then my third tract, last but not least, the land is also, and the soil is also the space you want to conquer. It is at the root of almost all conflicts in Africa and elsewhere. The concept of nation has been exported by the Europeans to Africa, and it's always been a bit difficult to define. But the concept of Westphalian states is simple. It's defined by borders and therefore by the soil. So even if we can discuss a lot about what a nation is and what an African nation is, there is no doubt that we can see what are the African states. The purpose of these round tables is not to discuss wars in Africa, except perhaps when war touches the first point of my small speech, the question of food security. Since the work of Amartya Sen, we all know that hunger stems less from problem of agricultural production than from insecurity. It is estimated that of the 150 million of Africans facing a hunger crisis, more than 80% live in conflict zone. The main cause of hunger in Africa remains by far war. In West Africa, in 2011, before the disintegration of Libya, there were about 20 million of people in a state of famine. Today, the figure is 50 million, and this trend follows exactly the explosion of violence in the region. War has also another consequence, which is the soil degradation and depletion of water resources. Indeed, when we look at Lake Chad, for instance, we see that the soils have become impoverished and water resources depleted, not because of climate change, or not only because of climate change, but because of overpopulation. And this overpopulation is itself partly due to the permanent displacement of population as a result of a conflict. So, at the end of the day, soil is certainly what is at the root of agricultural production, but it has many other consequences on the well-being of population, and I think we shouldn't forget this. This brings me back to my first concern of food security, which has to be addressed even before talking about food sovereignty. Let me stop here. The organizers of this roundtable have quite rightly chosen this unifying theme of soils for this year's edition. I want to congratulate them on this choice and wish you a fascinating debate. Thank you.
Thank you, Mr. Strauss. So thank you for your insightful presentation. And I want to highlight that soil is the critical component and important component in our university in different departments and especially in our College of Agriculture. And you mentioned climate change, biodiversity, and also sustainable intensification in Africa. And I want to highlight that those words are part of our DNA at the College of Agriculture, especially in our strategy. And also part of many, you talked about architecture, you talked about the importance of soil and what's soil, and also how it contributes to peace. So this is what I learned from your presentation. And thank you for your insightful presentation. So before starting our journey, I want to, since I'm the timekeeper, I have to present to you some 3 housekeeping items that I want you to keep in mind. So the first one is the agenda. So during this morning, we will have 3 talks, and followed by a lunch. Then we will have, during the afternoon, 2 talks, and a round table. So the same thing will happen during the second day. The second key point is an invitation to all speakers. So you will have 30-minute presentation, followed by 10-minute question from the public. And the third point is for you, dear attendees, to set your phone on silent mode, to expand our focus span, and also to take or to get the most of our morning session and also afternoon. So thank you very much. And yeah, our journey began with Professor Edward Bard. And let me introduce, I want to give him a nice presentation and introduction. So Professor Edward Bard is a member of the French, European, Belgian, and US Academies of Sciences. Professor at the Collège de France. Professor Bard will discuss a multimillennial perspective on hydroclimatic changes in North Africa, setting the stage for what I'm sure will be a series of insightful and forward-thinking discussion. The floor is yours.
Ladies and gentlemen, dear colleagues, dear students, so it's a real pleasure for me to be here, to participate to this 14th edition of the Tables Rondes de l'Arbois. And I would like first to thank, in fact, the organizers, President Helapti, Professor Daniel Naon, and all the people that were involved in this organization. I wanted also to emphasize that I came earlier, a couple of days ago, and I had a time to walk around the campus, so I was quite amazed and blown off by the size and the quality of what I've seen. This is amazing. It reminds me my first visit as at that time I just had my PhD. I was visiting Caltech, and this is really making me the same impression. To go in such a campus, so it's very impressive. So thank you again, and congratulations, thumb up for what you have constructed here. And yeah, this is an amazing campus for the future. My role here is to give you a perspective about hydroclimatic changes, especially in North Africa, but of course we need, in fact, first to speak about global climate. And we start by that with the first slide, if it goes. Yes. And this is just a slide that is recapitulating, in fact, the basics of the global warming. You have seen that several times. This is just an updated, on the left you have an updated view of the warming, of the compilation of the meteorological data over the last century and a half. I mean, starting at the end of the 19th century, the beginning of the Industrial Revolution, 1850. And these are anomalies based on the network of meteorological stations around the world, and also you have satellite data that are embedded to that, and all the curves show this massive warming over the last century. And when you see since the beginning of the 20th century, we have a warming about 1.5 degrees already. So this is the global picture on the right, not with the same scale, but with an expanded scale up to 5 degrees Celsius. You have both the actual data that we have measured, so the gray curve, and on the right, the projections that have been compiled by the IPCC based on about 30 modelization based on general circulation models in about 30 groups of modeling around the world. And they all converge towards showing us that we will go towards global warming with different sizes, different amplitude, and the amplitude obviously depends on the forcing, on the scenario of mainly CO2 emissions by burning of fossil fuels. So you have what could be referred as optimistic scenarios. In blue, you have pessimistic or more or less realistic scenarios that are represented in red, showing warming at the end of the 20th century up to 4-5 degrees Celsius. You have also an intermediate scenario showing a warming at the end of the 20th century of something like 3 degrees. We know that the optimistic scenarios are really utopic. They are beyond the capacity of what we can organize globally, so it's not even, they are a bit obsolete now. But, so this is the picture that we face, but of course this is at the global scale. This is just a curve that is compiling all the information. We need, in fact, more, especially if we want to look at the geography and the different areas where things will happen, it's important to put maps. And these are basically the same data shown on a global map. On the right, you have the warming map. I mean, these are data. These are not projections yet. These are the data plotted on the global grid, which is representing, in fact, the warming of year 2020 versus the beginning of the century. I mean, the end of the 19th century. What you can see is that everywhere it has warmed. There are a few places where the warming is minimal. For example, in the North Atlantic, you have a cold blob there. But definitely there are several distinct features that you should see on that map that are very important to understand the impact of global climate change. In general, climate change, warming is enhanced on continent. We have an amplification on the continent. You have also a very distinct amplification in polar zone, especially in the Arctic. We call that the Arctic amplification. And so you can see even for North Africa that there is an amplification when you compare, in fact, the warming on the ocean, on the Atlantic, and in North Africa. The right panel is more complicated to look at. These are the precipitation. And the precipitation changes are more variable, meaning that you have, over the last century, here this is a map showing the trend in millimeter per year per decade. For the last century, and what you can see is that you have places where the climate became wetter, in green, shown in green here. You have other places that dried up, shown in brown, and you have many places which are represented with X's, which illustrate that in these areas, for the moment, there is a non-significant trend. But you can see that the different pictures, the different areas where this is green or dry or yellow or brown are really coherent. They form a very coherent. It's not a random map. We can see that you have regional trends that are really significant. And this trend will continue in the future. This is just the two equivalent maps for the mean of all the models that were used and compiled by the IPCC for this intermediate scenario. Basically, the colors would be exactly the same if I would take the extreme or the optimistic scenarios. The only thing that would change is the scale. On the right, you have the global warming of 3 degrees globally, but you can see again that the warming is enhanced, is amplified on land, and you have this obvious Arctic amplification, and you still have the cold blob in the North Atlantic. And what is more problematic for us, and especially in Africa and around the Mediterranean, is that the contrast of the precipitation will be even more increased than in the data that I just showed to you. For example, you have a massive wetting of the climate in the high latitude. You have also in the subtropics, and especially around the Mediterranean, you have a drying all around the Mediterranean. Obviously, on that map, you should see also a very green area on the Sahara, and but I mean this is of course all maps have their own prime. It's not possible to represent all the complexity. This is represented as percent wetter or percent decrease of precipitation, and of course because of the precipitation is minimal, increasing by 40%, something that is small in the Sahara will not solve the problem of agriculture there. But anyway, for us today, I mean, the main focus is on the Mediterranean and the North Africa area, regions. It's possible to make a zoom with a zoom for that map. This is a zooming around the Mediterranean Sea. On the upper panel, you have the warming, very I mean, this is distinctively the same as what I described to you before. You have an enhanced amplification on land, both in Europe and in North Africa. And the map that is more of our concern today is the precipitation map, which is showing again the gradient with all countries around the Mediterranean that are drying. You can see that the worst case in that case, for that map is precisely on Morocco. And you have a gradient. The northern part of Europe will be wetter, and in between you have these gradients. So maybe some places will be happy and have exactly the same climate, but I mean, how can you survive in a completely destroyed climate with northern countries wetter and southern countries much drier? I mean, all those countries, especially central France, for example, here you see that there is no distinctive change because it's in the modeling. It's not still significant because, and you have to imagine that this is a mean. This is an average of many model simulations. Some of them are indicating a drying. Some of them are indicating a wetting. So in the end, this is not significant in this intermediate band, but clearly we will be also impacted in northern Europe, including France, and it's clear also that southern France is already part of this Mediterranean problem of dryness. So the last news on the problem are not very good, are bad actually. This I took from a very recent report that was published by the European agency called Copernicus, and this is based on precipitation data observation over the last months of 2023 and the January 24. And what is represented is the fact that most of the northern country here on that map have been wetter than normal, and you see also other places, especially Morocco, Algeria, and southern Spain, Sicily, that became much drier over that time period. So this is partly meteorology and the long-term trend. I mean, we have to recognize that it's not possible on that map to distinguish. I mean, it's not possible to say that this is entirely due to global warming and the long-term trend that we are modeling with the numerical models, but still, this is completely reminiscent of what will happen to us in the future. And another thing that is very important is that the vegetation is responding almost immediately. So the lower part of the panel is a map of the photosynthetic activity of vegetation that is measured by satellites. And it's possible to measure that real time. And this is the map of mid-January, and it's possible to see that the photosynthetic activity was larger than normal for most of the places where the climate was wetter, and the contrary is true. In Morocco, for example, where it was drier, photosynthetic activity decreased. So we are really facing a long-term trend, and already the features sometimes are really reminiscent of what will happen in the future. In order to really understand the impact of man-made climate change, I mean the influence mainly of greenhouse gases that is affecting, in fact, the radiative balance of the Earth, it's also important to look at natural climate variations, because of course everything is embedded. What we see are natural climate variation plus the human impact, and in order to do that we have to go beyond the last few centuries, and in order to do that we have to do what we call paleoclimatology. And in order to do paleoclimatology, usually it's not possible to use instrumental data, very precise thermometers and so on, satellite of course not, but in order to go back in time we need in fact to look at what we call paleoarchives, and one of them, for example, that is quite useful are sediments from lake sediments. And this is just an example of a picture taken from a work that was a collaboration between the lab of the Serege in Aix-en-Provence and the university in Marrakech, University Kadi Hayat, where we studied with a group of scientists the lake, a small lake in the Middle Atlas, the lake Azigza, and you have the bathymetry of the lake, and we took, in fact, sediment cores, and with these sediment cores, it's possible, in fact, to measure different properties, chemical properties, isotopic properties. We can also count pollens, for example, in order to reconstruct the climate, and also to see the relationship between the geochemical, sedimentological changes with the level of the lake, for example. So this is just a picture. I don't want to go into the details, but this is a picture taken from the same work with representation over the last century of the comparison between the geochemical data and the actual precipitation data and the lake level. And of course, all are coupled. And it's important, in fact, in order to go back in time to look precisely at the coupling between the geochemical proxies in the sediment and the meteorological data over the calibration time period, the last century, to be able to go back in time. One period of very much interest for paleoclimatologists is what is older than the last century. It is only a few thousand years, and it's called the African humid period. And you have probably all heard about it. I mean, about 9,000 years before the present, the Sahara was greener. It was not solid green with forest cover, but it was maybe pale green. But this is something that is known since many, many years, many decades. So this is a map, a summary map showing, in fact, the lake levels compared to today. And all lake levels, especially in North Africa, were higher than today. In some places that are shown on that graph, lakes do not exist today. They were present in the past during this African humid period, roughly between 11,000, 5,000 years before the present. And the reason why we are interested in that period is that we can test, in fact, our knowledge on past climate and modern climate to see if we can explain these changes. So this is a very amazing example of what was happening during this African humid period, is that the largest lake on Earth was the Lake Chad. And we call it Lake Mega Chad. During the African humid period, it was, so on that map you have the small, you can see that, for example, this is the present Lake Chad, and at that time it was going up to the desert and the Baudelaire Depression that is completely now in the middle of the desert. So it was a very large lake, larger than the Caspian Sea, which is actually the largest lake of fresh water on Earth today. So this is just to illustrate the size and the impact of this African humid period of the time. It's possible to look at the geomorphology of the Lake Mega-Chad. This has been done by several colleagues. This is a collaboration with French colleagues from, I think, Strasbourg. They were looking at details based on satellite geomorphology maps, and also they went on the field to check the features. And they have been able, for example, to look at very distinct features to show that there was a massive lake body at that time, with waves, with currents. And for example, this is in the middle of the desert they described what is referred in geomorphology as a coastal sand spit. And this is in the middle of the desert with you can observe that with satellites because there is no vegetation. And this is the equivalent in the Azov Sea in Ukraine today, with the Azov Sea obviously transporting the sand with the water. So this is just to illustrate the size of the event. The lakes were not only higher and larger and more frequent in this part of the world, but also the rivers were enhanced. So this is a map showing, in fact, the major rivers in North Africa. I mean, starting from the equator with the Congo, the Niger, the Nile, the Senegal. And during that time period, we had the evidence for a gigantic river that has now disappeared, which is called the Tamanrasset Paleo River, which is shown here. And this was discovered recently, actually, by radar satellite imagery. It's even possible, in fact, to look at the details. This is a detailed study that was done by these colleagues who studied the connection between the river on land, its features, its geomorphological features, and a canyon, an underwater canyon in the Atlantic. That is the proof that both of them were connected. This is immediately south of Cap Blanc. So a very important change of the rivers as well as the lake levels. And the other thing that we can do, and that we do as I will illustrate, is to study also ocean sediments. So we can work with paleo archives on land and also work with sediments, especially because in the sediment we can find different elements that are synthesized in the ocean, but also we can find dust, for example, dust flowing from the Sahara. So this is just a satellite picture of a sandstorm coming from the Sahara over Morocco in that case. And all that sand that you can see is transported and falls to the seafloor, and we can find that in the sediment. So several groups have been active in that area and have been looking at deep sea sediment core. So we go at sea offshore and we raise deep sea sediment core at 2 kilometer, 3 kilometer depths. So this is from a collaborative work with American colleagues from Columbia, from the MIT also. And in that study, these colleagues studied in different cores that are represented here, scattered at different latitudes between Cape Gear and Cape Blanc in 4 cores, and they studied the flux of dust within the ocean sediment. The dust is coming from the land, transported, the Saharan dust, and this is what we can find. And on that graph, you have, on the right panel, you have the time series of the change of the dust flux within the sediment. And you can see, I mean, the chronology here goes between 20,000 before the present to 0. So 0 is today, and the time is evolving from right to left. And what you can see is that the period that is highlighted in green between 12,000 and 5,000 years before the present is characterized by a massive drop of the amount of dust blown. And this is understandable. You had more vegetation and less desert, so clearly there was less dust blown by the winds to the ocean. So this is just a study at the different latitudes. It's possible to go beyond that by looking at isotopes. And the water isotopes today in rainfall, in water, in today's atmosphere, is the water H2O has two elements, hydrogen and oxygen, and it's possible to study the isotopes of both atoms, hydrogen, so the deuterium to hydrogen ratio, or the O18 to O16 ratio, and both of them are are inversely correlated. The delta D, the DH ratio, and the O18 to O16 ratio are correlated to the precipitation rate today in the modern rainfall. So in effect, this is providing us a tool in the past. If we can reconstruct the delta O18 or the delta D through time in this region, it's possible to go back and to calculate the precipitation rate in a more quantitative way. This is exactly what has been done in the cores, in the deep sea sediment cores that I was illustrating before, between Cape Gear and Cape Blanc. And you can see on the right the measurements, the records of the delta D, this D over H ratio, deuterium to hydrogen ratio, with distinct changes through time. So in that case, the plot is a bit complicated to interpret because the y-axis has been represented, inversely. So in fact, it is decreasing upward, just to show that during the African humid period, you have a decrease of the delta D, which means an increase of the precipitation. So everything confirms the basic big picture that there was a major increase of the precipitation at that time. It's possible also to go beyond and to go back, in fact, to the continent. This is what has been done by other colleagues, and we can do that with I think there was one slide missing. Anyway, I wanted to show you that there was a graph with a study of a lake in the Lake Tislit that was where colleagues, in fact, studied the pollens. And by looking at the pollens in the sediments of Lake Tislit, they were able, in fact, to reconstruct the past humidity, precipitation. It's possible to look at the abundance of trees versus shrubs, for example, and to see a very distinct increase of the amount of trees during the African humid period. And at the same time, it's possible by using what we call a statistical transfer function. It's even possible to use, in fact, the statistics of the different pollens to reconstruct the precipitation rate. So this is what they did, and this is basically confirming what has been shown with the isotopes, that during the African humid period, especially in Morocco, because all the data for Lake Tislit, that is in the High Atlas mountain, is representative of this area, and we can see that there is a distinct increase of the precipitation based on this data. So we are also in my lab at the CEREJ and in my team also interested by the prime. In fact, this is just showing, in fact, the few tools that we have been using recently to work on the prime. This is part of the organic geochemistry lab at the CEREJ. This is also a joint venture with the Collège de France in Aix-en-Provence, and so you have different apparatus facilities that we can use, mainly for what I want to show you today, GCMS and GC, gas chromatography and mass spectrometry. And it's very important to be able also to date the sediment. Obviously, if you want to be precise and you want to calculate rates of changes of precipitation, rates of warming, you need a precise chronology on these archives. And we do that with different techniques, but for the sediments that I will speak about, radiocarbon is the main dating technique, and this is just a plot, a graph, a picture showing our new accelerator that is dedicated, in fact, to carbon-14 dating in these archives. And what we have been doing, and for the moment it's completely preliminary, so it's very complementary to the efforts of the American colleagues on the different cores with dust, flux, and with with other proxies, and also colleagues at Serege working on lake sediments, and the ones also in Montpellier. The paper I was mentioning is Shedati et al. That was published in PNAS a few years ago, where they have studied the Lake Tislit. In our case, we work on a new deep sea sediment core that was collected again offshore Cape Gear at about 32 north. And what we do is to analyze the sediment at different depths, and we do gas chromatography. And what is interesting is that with the same sample in the same gas chromatogram, so this is just an example of a typical GC chromatogram that was measured on that core. We can study both the terrestrial plants and the phytoplankton, so plants in the ocean. So these molecules, I mean, I don't want to enter into the details. We can really pinpoint and do mass spectrometry to prove what these molecules are. All those molecules are called alkanons, and they are produced by the phytoplankton, and they help us, they allow us, in fact, to reconstruct paleo temperatures of the ocean, of the surface ocean. And at the same time, in the same sediment, what we find is also N-alkanes. N-alkanes, C27, 29, 31, 33, etc. So, and these are, in fact, leaf waxes that are transported from the land. They were on leaves, so this is a picture of just a leaf where you can see the leaf waxes. And these leaf waxes can be abraded, sandblasted by the winds when you have desert and a lot of wind and sand in the winds. They are transported to the ocean with the mineral dust, in fact. They are transported very similarly to the mineral dust as what we have seen. But in that case, they are indicative of the vegetation. So this is for the moment. So but what is marvelous is that in these sediments, you can measure both information, ocean and continent, terrestrial plants and marine plants. And this is just a graph, a very preliminary graph with a chronology that we are updating right now, with a plot showing both the sea surface temperature based on the alkanon. The sea surface temperature is represented in red. You can see a massive warming of more than 6 degrees at the beginning of the African humid period, then a decrease at the end of the African humid period. So this is a time of warming. And at the same time, you can see a massive drop, very similar to the dust-blown drop in the sediment during the African humid period, because there was less abrasion and sandblasting of these leaves on land and transport by the wind. So this is very distinct and very clear. And you have also other antiphases that are linked to details that I won't enter into. But this is already at that stage, we can see a lot of things. And of course, what is important is that we have to improve the chronology over that time period. So we are doing that with the carbon-14. And the main advantage of this core, in comparison to what our colleagues are doing, is that it is much longer. And we can go back, we know now that we can go back to 500,000 years before the present. And it's possible to discover other time of African humid period, because these African humid periods were cyclic, and they were caused by natural changes of the climate, mainly astronomy. So we are busy to understand all those past African humid periods. Some of them were even more intense than the one at 9,000 before the present. And this is really ongoing work at the Serege that we are doing, based on this dual approach with looking at terrestrial and plant and marine plants. Obviously, the other aspect that I want to describe in detail is the fact that in parallel to having to reconstruct paleo records, having paleo archives of all those changes, we need also to compare the data that we are reconstructing for that time period with the numerical simulation based on the models that are the very same models that are used for doing the projections and that are compiled by the IPCC. And this is just one example, that there is a full literature of attempts, of more or less failed attempts, and this is, the situation is improving, but it's continuing update and progress, but it's still not satisfactory completely. This is one recent, more or less, GCM model simulation, so general circulation model simulation, where the model is perturbed with the known paleo forcings, the insolation that we know through time, the irradiance of the sun. We also introduced what is known about the greenhouse gases, especially CO2, that was not very different from the pre-industrial at that time period. We also enter the vegetation cover, the soil cover, and also the lakes. For example, in that case, this simulation is taking into account the fact that there is a large lake, the Lake Megachad, which is also creating its own micro-environment and micro-climate. And on the left, you have the anomaly for temperatures. On the right, the anomaly for the precipitation. And you can see that there is a massive increase over whole North Africa of precipitation, but not quite, for example, for Morocco and the northern part of the Maghreb. It's not matching, in fact, what we see in the data. So it means really that we need to improve hand in hand with the modelers by looking at the correspondence between the data and the models that are exactly the same model as the one that are used for the IPCC. I see that my time is over, so I will leave you with now with a few take-home messages. I think that, it's not new to you, but this is the main concern, that all countries around the Mediterranean Sea have entered into a new climatic era. Besides ant warming, the main threat here and also in southern Europe is long-term decrease in precipitations. The vegetation, natural, and also the agriculture is suffering is because the vegetation and plants are tightly coupled to water availability. And there is this is the plea that I would like to convey during this short talk, is that there is a crucial need to work not only on modern climate, but also on past climate, because they hold the key to the discrimination between models, and also they work also towards improving the models. So they are used as tests for the models that are used also in projections for the future. It's clear that if a model is completely wrong for the African humid period, you cannot rely on it for believing its projection for the future. And it's clear also that the African humid period can be viewed as a climatology test bench. There are many archives that can be compared with this and with models. And there is active ongoing work in Europe, in America, and also in North Africa, including Morocco. Active work is ongoing on various paleoclimatic archives from marine, lacustrine sediments, and I did not have the time to mention also the cave sediments, what is called speleothems, that are also useful for that respect. And with this, I will leave you with, and thank you for your listening, and with a picture showing, in fact, remnants of a paleo lake in the middle of the desert, in that case in the Grand Terre Occidental. That picture was taken by Françoise Gasse, a pioneer of the field, who is deceased a few years ago, and who was working also at the Serrège in Aix-en-Provence. So this is just showing to you remnants of a paleo lake that no longer exists today. Thank you for your attention.
Thank you, Professor Bard. Actually, you presented some nice maps, pessimistic maps, in a room full of hopeful and optimistic people. And as a researcher, I think we have the duty to enhance the resilience of not only Moroccan farmers, but African farmers to climate change. So thank you, Professor. We will take 10-minute questions, followed by a break. But quick reminder for you attendees is to present yourself if you are willing to ask a question, and avoid long comment, so we can take advantage of the break for more connection and discussion. Thank you. So the first question. I have one. So, yeah. So at the UM6P, we are studying, I know many colleagues are studying the impact of climate change on agriculture. And you presented the effect on the vegetation. And we know that the yield and vegetation are quite correlated. So in your opinion, what's the role of researcher in agriculture to enhance resilience to climate change, effect on Mediterranean?
It's clear that
Should we adopt new crops? Should we think about
I mean,
changing
probably-
our...
Yeah. Okay. The response, from my point of view, is yes, but I'm not competent on this aspect. So I would, it's clear that we will, I mean, agriculture has to change because of climate change. It already has done that in several parts of the world, and it's inescapable. I mean, there is no way we can, and the agriculture can stay the same as we know it today. So it's, and at the same time, scientific research can help us to improve crops, improve also the selection between crops. And in that case, here it's something that is outside my expertise. This is agronomy, and soil science, for example, is also embedded and involved in that topic. So clearly, this is where, people should listen more to scientists. You know, we are complaining that most people don't listen as much to scientists in climate changes, in climate science, but this is the same for scientists also in agronomy and soil science. At the same time, we have also to learn from our past mistakes. In fact, all scientists have collectively also done, especially in Europe, done mistakes in believing that climate would be stable, and we see that with climate change, we need, in fact, to revise that and adapt and probably change the process. But the only thing that will help us will be to follow science, I think. That's obvious.
And also synergies between disciplines. So we have a question, Professor Hijri.
Can you hear me? Wait, thank you. Thank you very much. Two questions. So the first one is a technical question. So you have used leaf wax, which is organic alkane, as a proxy for determining your measurement. Did you know that these, organic compounds could be degraded by microbes? And if yes, how you dealt with that issue?
I mean, yeah, when you look at an alkane, you look at the distribution, and the distribution is clearly linked to terrestrial plants. For example, I mean, you could have also alkanes that are linked to contamination by oil products. And in that case, as you have seen, what we have are mainly odd alkane, not even alkanes. And of course, if we had crude oil, we would see paraffin, so we would see even carbon number chains and alkanes, which is not the case. We see, and we can even study some ratios between the different alkanes that are really pinpointing to the vegetation. So it's not a microbial input, clearly. And actually, these are also the same molecules in which deuterium can be measured. So we can see that there is a link between the two proxies.
Compound could be eaten by microbes.
Yeah, they could be. Okay. Yeah. So, you could have but why would, I mean, when you see the changes in the sediment, clearly they completely match what we know from the mineral dust. So there is no way, so the changes that we see cannot be affected by a bias that is completely due to microbial degradation in one place for one period to another one. So there is, and the sediments are pretty much homogeneous. In fact, you can't see these layers. It's not like a lake sediment where you can see very strong changes of the organic matter content. In that case, in these sediments, you have less than 2% of organic matter, usually 1% of total organic carbon are in this sediment. So they are more or less homogeneous. So why microbes would eat more here than there, I have doubts. But anyway, the fact that we have coherent changes, and this is also something that is very important in paleoclimatology. It's clear that by looking at paleoclimatic proxies and archives, we cannot compete with the precision that we can get with instrumental data, with thermometers, with satellites. It's clear. So it's only by having a redundant approach by trying to study the same thing, precipitation, with different tools, pollens, isotopes, geochemical data, lake sediments, ocean sediments, that when we get something in agreement, we can say that something is quantified.
So my last question is, we have now so many variations in precipitations, increasing in temperature, and these are really very fast for plant to adapt. I want just have your comment on that. Because adaptation will require a lot of time for plants to adapt to these variations.
Again, this is really ongoing work, but the fact that you have at the beginning, in the case of Cap Gear, what I just showed, which is completely still preliminary, and we are working on the dating, but it won't change the big picture. The fact that you have 6 degrees of warming, it's enormous. It's much larger than what is predicted for the end of the century. 6 degrees in only a few centuries, and a massive change of the precipitation tells you that also looking at these past changes is interesting, to look at the speed of these changes. And I mean, one of the main questions on the topic of the African humid period is not so much the beginning of this period, but it's the end. Why was it so abrupt? And here, okay, there is a full literature about feedbacks to understand why the African humid period terminated at 5,000 years before the present, and in only a few centuries. So it's very bizarre and amazing, and it's only by looking at the details and modeling in a complex way, by taking into account the vegetation in the models, that you can produce that very rapid changes. But again, looking at the past is also informative on the rates, not only on the amplitudes.
Thank you very much for the presentation. I've just got one question. You talked about the new era that we are entering, right, the climate era. And I was wondering, is there any place in the world which has gone through this era? And can we draw any lessons from any of those places in the world?
You mean a place in the world where there is no change, or where...
which has experienced the new era we are entering into?
The main problem is that we are, the meteorology, I mean, here we are going back, in fact, to the distinction between meteorology and climate. Climate is more or less, I mean, to the mean meteorological conditions average over 30 years. I mean, it's not exactly that, but it's a good way of looking at it. And obviously, when you see even the Copernicus changes that I showed for only a few months, it's extremely difficult to say what is the percentage of that change that is due to man-made and the long-term trend, and an extreme event that is due to synoptic meteorological conditions over this. But this is more or less reminiscent of what will happen in the future in all the models. So that this is, and this is also the reason why it's, I mean, since 20 years I've been talking about climate change. You know, one particular meteorological event, even an extreme event, a big flood or a dryness event, it's never possible to be 100% sure that it is attributed to the long-term trend. And this is one of the difficulties, because, for example, if you want to convince people to do something, they need to be convinced that it will solve the problem, especially if you interact with politicians. They want real solution. They want scientists being sure at 100%. And there is, in meteorology, it's not possible.
Last question.
Yes, thank you. Thank you, Professor Barr, for sharing with us this very interesting data about this hydroclimate change. My question is about, you have touched on the the increase of temperature and also disappearing of some lakes. But how about the floats? The inverse, will this hydroclimate change impact the frequency of these extreme events, hydroclimate extreme events like floats, like we have seen last 2 weeks in Dubai?
Yeah, I think it's also a fact that is now well established that most extreme events will will be increased in the future. But of course, the drawback is that still over the next several years, it will never be possible to attribute a 100% certainty that an extreme event, a flood event, is 100% linked to the global warming, the man-made global warming, and that's one of the points. But it's clear that in all the projections, we will face, in fact, more extreme events, and this is what modeling is telling us, and this is also true for hurricanes, for cyclones, and storms and flood events.
Thank you. So we will go for a very short break. We will give you 7 minutes to bring your coffee here, and during the 3 minutes, we will start calling you to come back. So please try to come back as soon as you grab your coffee.
So like with health, that is not only absence of disease, food security is not only absence of hunger. It is, of course, a very complex affair. And I could, if you were my students, we could take this for a whole semester and go through all these things. It has to do with political issues, it has to do with rural poverty, it has to do with everything you just can imagine being of importance with regard to sustainable development. And some of them I just want to pick out. But the point is here, we are talking about wicked problems. A wicked problem is defined as a problem that you cannot understand without knowing about its context, and one cannot meaningfully search for information without the orientation of a solution. So, if people think hunger is basically a soil issue, they will focus on that. If people think hunger is basically a political issue, they will focus on that, and so on. And as a matter of fact, and as we all know, it's part of everything that we are discussing. The choice of explanation and the worldview of the observers determine the nature of the solution. And what I'm trying to do is, there is so much specific knowledge in the depth of it. And what we need is to kind of cover that with a orientation knowledge that brings all the different aspects together, because only then do you have a chance to really make progress. Today is a very special day. Never before in human history were so many people living on Earth. Today it's more than 1.8 billion. And the world population is still increasing every day by about 200,000. And there will be, while I am talking here, there will be hundreds of new babies born and to live here. But from a question of food security, urbanization is as important, because urban people eat differently and they need more calories, and more calories at the end means a higher production. And if we look at sub-Saharan Africa, the number of people that are going to live in cities are also a tremendous political force, because it's always urban elites that create political changes. It's not the rural poor that do that. At the same time, we have a, how shall I say, Arab land is decreasing, and Arab land is anyhow a crucial source, and it's this part of the wicked problem. You can have more arable land by cutting down forests, but that is creating other problems. So, take it as a fact and then see what we are going. And, this, of course, is the question of our generation. And what my predecessor has been saying, if you talk to people like Jim Hansen, or to people like Johan Rockström, they all tell you what's discussed by the IPCC is underestimating the issue, because they do not take into consideration a lot of interdependencies that have an accelerating effect. So, what we should, and the question, if you talk to them, the question is not the 1.5 degree. They say that's dead long ago. The 2 degree target is on the deathbed. So what we should do, in addition to mitigating climate change, is building up resilience, because it will come. And these are slow-moving systems. All of them that I'm going to mention here are slow-moving systems. If we start changing today, it takes 5 to 10 years before we feel an impact. And with some of these, we just do not necessarily have the time to do that. And as it has been so difficult to understand that if the knowledge is here, why don't the politics change? It has to do with the accountability period. If you want to be re-elected every 4 years, you have a different time horizon than if you want to prevent climate change over the next 25 years. But it is climate, it is natural resources, it is energy, and it has an impact on all these factors like agricultural policy, trade, labor, finance, technology. And it says here geopolitics, but it is very much also a good governance issue and local politics, and Dominique Strauss-Kahn has mentioned that. I think you have a lot of experience with the Monetary Fund that teaches you the importance of that. The impact of the war has been the last trigger 2 years ago. You know that this war has led to higher energy prices, it has disrupted trade, it has, you know, it created a lot of additional problems in a vulnerable system. And if we have social unrest in a given country, as I said, basically triggered by urban people, it makes everything much more difficult to solve. And, you know, food prices very much depend on the global availability. But, imports of food might be a temporary solution, but in the end, what we all strive for is food security being built on sufficient local production that makes you independent on trade. And by the way, it also mitigates climate change for a variety of other reasons. Now, the point here is that poverty is increasing at the moment. We have made tremendous success on the poverty front in the last 15 to 20 years. At the moment, there is a deepening global food insecurity, and it has to do with poverty, vulnerability to extreme poverty. If food prices rise by 1%, extreme poverty will be affecting 10 million more people. And it's this vicious circle that is created. If people are poorer, they will be less able, even if they are willing, less able to build local resilience without the help of external forces. And what again Dominique Strauss-Kahn said, you know, it would be so much less expensive if the international community would come up with the resources needed to act now than what it eventually costs. And here we are again, time horizons of politicians, somebody who wants to be re-elected in the next 3 to 5 years is not very much interested what happens in 30 years because that's beyond his control. Now, what does that mean for strategies? First of all, it has to do with integrity and with honesty. If you listen at all the G20 or the G7 conferences and all the political commitments, and you wonder, there are always, you know, something is happening, but it's not always happening what has been promised. And here, at least in my conviction, good governance is the most important strategic cornerstone. Dominique Strauss mentioned this morning Amartya Sen. Amartya Sen was also coming up with the empirical evidence that wherever you have a free press, you are not likely to have a hunger catastrophe, because a free press will early enough talk about these things and create pressure, exert pressure on those who have the political power. So good governance, but also democratic processes, government spending according to the structure of the socio-economic problems, and nothing else. Deliver on promises made, development cooperation, also less protectionism. It's astonishing if you go into the details what, for example, the European community is still allowing itself with regard to protectionism to the detriment of poor countries. It's astonishing. Comparing the facts and comparing the language is an interesting game. As I said, complex problems do not have simple solutions, and initiatives by one actor only, as well meant as it is and as big the resources are not likely to do more than a temporary effect, and then they sip away. So what we have to create is multidisciplinary stakeholder partnerships to effectively address complexity of causes and cross-sectoral nature of food insecurity. What I mean here is we have, for example, in this room, we would have a lot of deep knowledge about specific things, but what can we do to bring this together to one negotiation table or to one table where researchers are, sitting together, a macro analysis for that matter. Embed technological solutions in a wider socio-economic and cultural context. I have been fighting for the last 30 years on green genetic engineering. That was even before CRISPR-Cas. And I was working for a chemical company, and of course I was under the suspicion of doing propaganda for the capitalism guys. Bullshit. If you see what you can do today with CRISPR-Cas, you can adapt plants to be more resilient and to grow better under worse conditions. Why should we not use that? The European, at least the German NGO discussion on that is that it can create more inequity, that the rich will benefit more than the poor. My conviction is that as long as the poor do benefit, I couldn't care less that somebody else benefits as well. So let's look at technology as a tool, and let's embed it in the socio-economic structures we are dealing with, and then let's find ways and means also with regard to intellectual property. Let's find ways and means that we can afford soft licenses, that we make technology transfer as part of the development cooperation. And it doesn't help if in Germany or in France or in the United States you find a wonderful solution for a specific problem, but it's patented and the price is so high that it is impossible to be used for sub-Saharan Africa. There, you have to create, to afford the creativity and the consequences. Now, strengthen multidisciplinary approach. Soil health is one of the few factors where something substantial can be done without changing the whole system. With proper application of fertilizer, you can do a lot for the rural income, for the quality of the production, for the productivity, without having politics to change, without having trade patterns to change. And this can start a cumulative process upwards, and this is why what we are discussing here is so important. Improve resilience as well as raise yields of food crops. I'm living in the Black Forest, and I see that if you talk to a maize farmer, he has his complaints, or she. If you talk to a wine farmer, they have hopes because of more sun, but also complaints. It has rained much more in the first quarter than it usually rains, so that creates another problem and opportunity. And it is much warmer. The nature in Germany, where I live, is 4 weeks ahead. Now, farmers can react to that with small adaptations, but taking it into consideration and giving the right incentives from agricultural policy would strengthen that kind of work. Improve local agricultural policies. Of course, what's appropriate in Niger or in Morocco must not necessarily be appropriate in Germany or in Brazil. So, while we know what are the most important pillars of an appropriate technology, of appropriate policy, we have to adapt it to the local conditions. And one of the things that I always repeat in this context is, let's also listen to the traditional knowledge of the farmers. They know something that is of value too, and it, combined with the most modern technologies and policies, we can make progress. Last but not least, with everything we are doing, we have to analyze the impact on the poor segments of society. For 800 to 900 million people in the world, the most important fight to win is the fight for daily survival. And small little things like the bread price, for example, can create a real life-threatening situation. So here, the state and the international community have a task to leave no one behind. This is what the 2015 Agenda 2030 for Sustainable Development is saying in its foreword. The good governance, to me, is always something that we have to have in mind. It has to do with corruption. It has to do with money going into the wrong pockets instead of being appropriately invested. You know, while we will not change this overnight, much more care with regard to the international banking system would help here as well. Now, what does that mean for sub-Saharan Africa? And, you know, here this is, Dominic Strauss-Kahn said, you know, what was the productivity increase of Asia? It had to do with a green revolution that never happened in sub-Saharan Africa. Now, why did it not happen? It has to do with research priorities. It has to do with numbers of people. It has to do also with skeptical people in the north. I was some time ago part of the CIMMYT board, and I was proclaiming then, you know, let's use genetic engineering for insect resistance. And the answer was, no, we cannot use genetic engineering because some of the donors in the north will not continue to fund us if we go into genetic engineering. Imagine, political ideology in the end determines a research policy that does not take benefit of all the advantages that you can have. Diversification of agriculture, and this is also sometimes forgotten. If we raise the productivity of the small farmer, he or she would not have to dedicate all of her land to food crops. Maybe she has some land for cash crops, and that would improve the household income. Social security systems for poor family, cash and buffer stocks, focused research that combines risk reduction, resilience, as well as increased productivity and climate change mitigation, increased inclusion of genetic engineering and digital technologies to promote innovative solutions, increased inclusion of social research to assess the social impact. And this leads me to asking for stakeholder stakeholder approaches. If we get my life experiences with people that are, with good-willing people, everything can be achieved. If there is a lack of goodwill, nothing can be achieved, regardless of the resources that are there. The compass for the next 10 years will still be the Agenda 2030. You will see that most of these things seem to be different priorities, different interactions. Some of those targets contradict each other. But if we focus at goal 1, no poverty, goal 2, zero hunger, goal 3, good health, the rest will come much easier. And there, of course, let's think of the gender dimension that we also find, you know, can bring the substantial progress that we have seen with maternal health and with child health into other diseases later on. This is what I wanted to say, and it's important. Why was I saying this? Again, my life experience, and at the University of Basel, every faculty has its champions. And these champions are looking that their faculty is looking best. So whenever there is a fight for money, profile your faculty, the money will come there. Will they talk to other faculties? Not if it is about limited resources having to be allocated. Now, it's this, how shall I say, it's a professional deficit that is happening in a lot of universities. same thing might happen in a government where different ministries, instead of putting money together for the same purpose, they go different ways. This is all known. However, let us start maybe here at UM6P of bringing together a solution stakeholder group, and let's look for one country or for 3 countries where we can apply such an approach, and the success we will probably achieve might be attractive enough that others can follow. Thank you.
Thank you, Professor, for your insightful presentation. And I'm sure here in the room, everyone is finding himself thinking or working on a solution. And Professor Leisinger, he cited twice my life experience, and it's something we can't find using AI tools, ChatGPT or anything else. So I invite you all, dear attendees, to interact with the panelists to get the most of their life experiences. Thank you, Professor. Time for a few questions. Yes, Professor.
Hi, thank you very much for your interesting and very, I think, enlightened approach to soil. So I am a research scientist and a resilient scientist. I think it was very much related to what I have been doing over the past 15 years. And when I was doing my PhD back in the UK, one of the challenges I actually faced was to bring this approach of addressing the ego problem. So academia has an ego problem. They talk about wicked problems, complex problems, but they really are not prepared emotionally to connect with interdependencies. And when we talk about different interdependencies, I think we need to understand that we need to bring ourselves to the solution. And I think, yes, we do need a better approach to soil, better approach to many things. In fact, we need a better approach to life. But I don't think that we are talking enough about how can we change ourselves. The soil, I think, actually begins within ourselves, the soil of our own minds. And I wondered whether you could share some of your own feelings or thoughts that what could be a way to include the inner soil, if I can call it that way.
Well, I can give you an anecdote from my academic career. I did the first interdisciplinary postdoc at the University of Basel. And everybody thought, oh, that's great, we have an interdisciplinary postdoc. But then the economists at the end said, that's not economic enough. The sociologists say, that's not sociological enough. And then everybody made a comment, and it was at the end a political decision to accept that kind of work. I think, I cannot give you a general solution. I can only tell you, if you have a choice, work with people who understand what it's all about. Work with people who are tolerant enough to accept thoughts and approaches that have not been traditionally the backbone of that specific department or that specific institutions. Because, innovation always starts with a very small group of people who have the will to think out of the box and have the power to resist to institutional forces that want to keep things together.
Thank you, Professor.
My name is Virginia Chaitin. I'm here at the UM6P at the Institute for Advanced Studies. Thank you very much for your talk. I am a epistemologist. My specialty is trans, cross-disciplinary studies. And I have to say that your talk today was so important to me because I'm writing a paper on this and right now. I sometimes feel overwhelmed by the incredible silo culture that is everywhere. It's in the educational level, it's at the research level, and then it's at the professional realm. And I think that we need talks like yours to happen every day in different parts of the academic and the professional realm, so that people really realize that the wicked problems, we can map them, we can study them, research, model them, but it is, as Shima said, it's within ourselves, the human beings, that really have to have a different attitude. Why is it so difficult to change the silo culture? And I have, like a dream of a different form of education. It has to really to start, with the kids that are 4, 5, 6 years old, the way you teach them, math, geography, history, but we don't have the time. We have to do it now, right? We are adults and we have to try to do it now. So thank you really very much for your talk, and I would just like to share this.
Thank you very much for your comment. I take the comment 100%. I do not have to answer to that.
Oh, okay. Thank you so much, Prof. Klaus. I'm Ruth Onyango from Kenya, and I think I've listened to you before. I also did an interdisciplinary master's degree, and I keep wondering for the SDGs, SDG 17, there must have been a reason for it, partnerships. But it's like we just mention other SDGs and we forget about this partnership SDG. Personally, I don't think we are going to solve any world problem, if we don't work together and change our mindset. And I just agree with the previous speakers and really sympathize with the young lady here, that those of us who have been around are not even able to tackle this. And it's over and over again. So, I don't know, what can I ask you? It's just, in our age has lost it completely. But maybe with young people who are like her, maybe we can begin to address something. But without it, we can't really. But thank you so much for sharing that.
Asante sana. All my children are born in Nairobi, so I know exactly what you're talking about. But it's la comédie humaine. You can talk to different people who are part of the problem, and they have the blind spot that they have to change. And people tend to look for the problems outside of their own sphere of influence, and there is so much you can do in your own sphere of influence. And by the way, thank you for the reminder. The goal 17 is about partnership, and it's as important as all the others. Maybe none of the others can be achieved without the proper partnerships.
Yes, to you.
Can you go? Yeah, just a comment. I'm really pleased that you have mentioned, the use of these technologies, CRISPR-Cas. But just to inform, the audience, actually, it's a whole research access at the African Genome Center. And we have now a international team, that is in place not only for plants, but also for animals. And we are working actually to establish a platform to use the technology for African crops, but also to build a training program. Yes, here.
Wonderful. This is, and I do hope, speaking about partnership, I do hope that, the departments in the different G7 countries, the departments that deal with development cooperation, that they take technology transfer of this kind much more important. I am aware that there are ethical issues. I am aware that that you can do with one and the same technology wonderful things and very bad things. I am aware that you can change viruses and use it in chemical warfare. I know all that. So if you have the proper governance and safety installations at a university like UM6B, you can also prove that whatever is done in Stanford or in Cambridge or in Berlin, for that matter, that you can do something that is as well done and much more focused to local needs. And that is primarily plant and secondarily animals. And about human beings, we would have to have another seminar to really discuss that in depth.
Yes. No. Thank you, Dr. Leisinger, for the thoughts and also the nice presentation. So you mentioned it, and you said words about intellectual properties, technology transfer. And mainly you stressed the fact that licensing should be soft. So how could this be soft licensing when private organization, semi-public organization, and even public organizations are looking for return on investment on their intellectual property? And if you could share also any practical experience in this soft licensing. Thanks.
Okay. How much time do you have? The point is here, I have worked for a pharmaceutical company. And my problem there was that you have the latest cancer therapies who can work wonders, but they cost between $500,000 and $900,000 a year, which means 0.1% of the world population is able to afford it. Now, going away from this, I was involved in the COVID-19 vaccination work, where the criticism early on came, while they are buffering stocks in the G7, nothing goes to sub-Saharan Africa, and so the value of life is not exactly the same. Why do soft licenses, and by the way, BioNTech, instead of giving a soft license, is producing in Rwanda so that they have the technology in their own hands? Why? Because the mRNA technology they are using has primarily been focused to cancer. And they do not want to give something away for a COVID vaccine that is costing them billions even when they have cancer medicine or cancer vaccinations. That's the reason. But in the end, it's a financial problem. And who pays for what? And I think they are, my guess, and I do not have much experience with the Monetary Fund or with the World Bank, but I know the funds are here. The funds are available. We are spending $2,300 billion on weapons this year. So nobody should tell me the money is not there. How can we do that? It's again about negotiations. It's again about creating pilots and show that it works. There is nothing more successful and more attractive than succeeding in an empirically provable way.
Thank you so much, Professor, for your presentation. During your presentation, while you were talking about strategies to address food insecurity in Africa, so you talked about combining farmer traditional knowledge with technology. I'm here. So you talked about that it will be good if we can combine farmer traditional knowledge with technology. But back then, I'm from Nigeria, and while in Nigeria, I worked with a company. We deal with fertilizer, and we have different programs with farmers in Nigeria, but we always find it very, very difficult to introduce technology or innovative idea to farmers. So because farmers, as you know, they are people that they have their own traditional knowledge. Before you can convince them, we always find it difficult. We have different, a lot of farm demonstration, teach them how to apply fertilizer, a lot of things. But to adopt it, we find it very, very difficult. From your experience, how can we effectively and successfully convince the farmer to accept technology or to combine traditional knowledge with technology? Thank you so much, sir.
I cannot give you a model answer for that. What I have seen, I did some research on malaria and leprosy and traditional doctors in sub-Saharan Africa and in India. And I found two kinds of problems. I found the arrogance of the Western doctors who would not want to talk to them what they thought are quacks. And I saw the other side who was intimidated by the white coats and the stethoscope. And you know, you will have to create a level playing field and an eye contact to facilitate that. The second thing is, yes, something that was appropriate 50 years ago and is still in the head of elder statesmen in the rural areas might not longer be appropriate one-to-one because the situation has changed, the rain patterns have changed, the climate change came in and whatever there is. But, you know, there is no systematic evaluation of how did they deal with particular crises earlier on. And you know, it's still true that every old human being, woman or man dying, takes a library along into the grave, because that traditional knowledge is no longer available if we don't go out and collect it now. And I'm not an idealist and I'm not naive. I don't think we can solve today's problems with the recipes of 100 years ago. But, you know, they have been successful over so many decades under awkward conditions and they still survived. So there must be something that we ought to know, and we might be able to apply it or not, but we ought to know it.
We can afford 2 additional questions.
Yeah, please.
Yeah, I can see.
I'm standing between you and food, so please.
Ngoni, usually you have questions, a lot of problems. You have solutions for many problems, so please. Do you have any question in mind? Really?
Okay, then.
Yes, Professor.
Good.
Thank you very much for your speak, first of all. Just following up the question of the colleague, probably I think that now that we are facing this huge increase of the number of population on Earth, this could be the problem that the farmer traditional recipes could not actually function as much as before. And probably also because of the existence of some ethical implications for example, for the genetic engineering. And this was actually the question I wanted to ask, if there are any raised ethical implications for this method or not. Thank you.
Did I get the question appropriate? Are there difficulties to implement modern technologies? Is that the issue? I don't hear you.
Okay. Because before they were, for the traditional farmer recipes, they were used just for small, like tribes or small villages, just to feed small amount of people. But now we have this problem of having like 8 billion of people on Earth. If we can use these traditional recipes, for large scale. Yeah.
Well, 2 things. First of all, I do believe in a dual agriculture. I do believe that we on the one hand have to make sure that small farmers and their families can live off the little resources they have without running risks that they run, that they are hungry. We are not going, my conviction, we are not going to feed the big cities, neither in Asia nor in Africa, with surpluses from small farmers. We need an additional, a kind of agricultural, a kind of industrial agriculture to feed the big cities, and there you will use a different technology than you will use for the small farmers. The point that I wanted to make is I want the wisdom of the traditional farmers in sub-Saharan Africa, but also in Southeast Asia. I want that to be used in the research circle that is discussing what kind of strategies make sense under what kind of conditions. It's that element of additional information, if not wisdom, that could bring new thinking and new results. Eventually, the results, the technological results that we have will not be much influenced by that traditional wisdom, but the application of these results probably are influenced by the traditional knowledge.
Good. Thank you, dear attendees. I'm sure that there are hundreds of questions, but yeah. Some people are shy, some people, they don't waste time, but whatever the case is, we are happy to share this time with you, with Professor Klaus Leisinger, and I'm pretty sure that your insights are very important for me and for attendees, especially that we have here students, we have researchers who may be sometimes confused about I'm talking about myself too, about what the speciality they are working on. It's a question that I've been asked since I joined university. What's your speciality? What do you major on? What you really do? And I found myself, okay, I'm not doing breeding, I'm not doing agronomy, I'm working with, but what really am I doing here? But I found some answers on your, it's very uncomfortable to be in such situation, but when we find that some people are like that, some people have the ability and the courage to think systematically about a problem. So thank you very much for your insights. And during the afternoon session, we will receive Professor Jean-Yves Le Gall, and also Professor Katia Laval. And now I'm inviting you to the lunch break, and we will be back here at 2:30 for more presentation and more exchange. Thank you.